to get on here, and then we're going to go ahead and get started, because I know you guys are happy to have fast sessions and then get back to your busy summer. Today, we are starting the next part of our summer review. Oh, wait a minute. I got to figure out how to do this with my screen on. There we go. And this is the one that is units 1 through 6. So we have been using the units 1 through 4. Now, the 1 through 6 here, if you guys have been very attentive, you might have noticed that the placement test is also from this same piece of paper. So if you're one of the students who still needs to get a problem or two fixed on your placement test, this is going to be your cheat sheet for that, because they're actually the exact same problems. Today we're doing pages 101 and 102. And no, it is not cheating to go ahead and fill out your sheet while we're doing it in class. That, as long as you're understanding what you're writing down, please feel free to do that. You can submit it right away without any problem. There's Glory. Glory, how are you today?
Good, I guess.
Excellent. So we are going to meet today, and then we have one more meeting in the summertime. That will be it. So it's this Tuesday and next Tuesday, and then you will not have to see me for a couple weeks until we hop in the fall. But hopefully your brain will be in math mode a little bit.
Where is the email? Where do we get the second paper from, the other page?
I can put it in Slack really quick if you don't have it. Is there anyone else who doesn't have it besides Brady?
Which paper are we doing?
It's the cumulative review form A of units 1 through 6. But I can upload it quick into Slack. Just give me 2 shakes, as they say. So we're getting into the harder stuff these next 2 weeks, because this is closer to where we're going to be jumping in with Algebra 2. So if it feels a little harder, it's not just you. It is a little bit harder. We're getting into the polynomials and the more complex factoring and things like that. So ask questions, pay attention, and you should be just fine. Because it still is review. It's just harder review. All right, I am looking in our Algebra Slack channel, and I'll just put it in the channel that says Algebra 2, because I didn't make one specifically for the summer review. And I'm attaching the file, so it should be available shortly. Okay, it is in Slack now. So the other question I wanted to ask you all before we jumped over to our shared screen to look and annotate is, last week we tried a Kahoot and saw, how a Kahoot might work for the time that we're doing online learning instead of in-person learning in particular, because it's an electronic form of assessment. Today, I would like to try a Quizlet Live. So using your participants button, if you have ever done a Quizlet Live, please click the yes button. If you're like, I've never done that, I don't know what Quizlet is, please click the no button. So far, I see 3 yeses. And Brady, have you done Quizlet Live? Sophia's never done it.
Not that I know of, no.
You have not? Okay, Jack, have you ever done a Quizlet Live?
I believe so.
Okay, and Garrett, how about you?
No.
No, all right. Well, it will be an experiment then. We'll review the 2 questions that are on the same topic as the Quizlet Live, and then we'll use the Quizlet Live as kind of like our break. I have to open my chat down there. Oh, Dylan says he loves Quizlet Live. Well, excellent. Okay, I'm going to go ahead and share my screen, and we are going to jump right on in. Let me get back to annotate over here. Okay, is everybody looking at the online version of the review form for today? If you cannot see it, you need to unmute and let me know, because I'm assuming that you can. And while I'm over in the shared screen, Emma, if you could just keep track of people having questions or putting something in the chat or something that I wouldn't notice and let me know, that would be fabulous. All right, first thing we want to do is we want to look at the what and the how of the instructions. So the instructions for problem 1 and 2 say simplify. So simplify means we are going to get an easier to understand version of the data that is in front of us. And then when it says the how they want us to do it, it's very specific that the answer that we write as a simplified answer has to have a positive exponent. And the basic rule that we should remember when we're dealing with exponents, positive and negative exponents, is we're not talking about the integer that goes in front of the placeholder. We're talking about the little superscripted number that's on top. And if I have something like this, x to the negative 4th power, you could think of that as a fraction. So like you could just put it over 1. That is the same thing as moving the x down from the numerator to the denominator. So it's going to go down here and giving it a positive exponent. So 1 over x to the 4th power is the exact same value as x to the negative 4th power over 1. All right. Glory, you get to pick who goes first today. You can pick yourself or you can pick somebody else.
I pick me.
All right. So our term here, we have just a single term, has this coefficient, and then it has this placeholder x and the data associated with it, and then it has this placeholder y and the data associated with that. When you are simplifying, which parts are you going to have to change? Like, do you have to change the negative 5 in any way?
Not necessarily. I'm not
Correct.
sure.
You need to change the x to the negative 4th power to simplify.
Yes.
Yes. And do you need to change the x or the y to the 0 power?
No.
Actually, yes. So another thing to remind yourself, if you have something to the 1st power, it equals itself. But if you have something to the 0 power, it equals 1. So there's 2 parts that you are working on here. All right. So we said we didn't have to do anything with our negative 5. What are you going to do with the x to the negative 4th power?
Should you make it not negative?
Right? How are you going to do that? That's right.
You add a positive
Stuff.
Oh, yeah, you turn it into 1 over x to the 4th power.
All right, so I'll just do that. Times 1 over x to the 4th power. And then what do you do with that y to the 0?
You do the same thing. So 1 over y to the 0 power. Wait, that doesn't sound right.
Well, if I can write that, what is y to the 0 power?
Oh, I forgot when you said it earlier.
It's over on the side over here.
It's 1.
It's 1. So
Y is just 1.
y is just 1. All right, now simplify that stuff to our answer.
Okay,
It will probably help you if you think of all of them as fractions.
Yeah.
All right.
-5 over x to the 4th plus 5.
Where'd you get a +5?
Well, I don't know where the plus is coming from. -5? -5.
I don't know where you got a -5 from either. You have the -5. This -5 is this -5 is this -5. So you already took care of that. So you have -5 times 1 times 1 is just -5. And then multiplying your denominators, 1 times x to the 4th times 1 is what?
1, or x to the 4th.
Yeah.
1.
Because anything times 1 is just itself. So this is indeed the simplified version of the answer. The y just completely dropped off the universe because it turned into a 1. The -5 stayed exactly where it was, and then the x to the -4th moved to the denominator. So this is the right answer. Okay, does anybody have any questions about number 1 before we move to number 2? Nope. All right, thank you for that green check mark. Glory, pick somebody to work on number 2, which is another negative exponent type problem.
Okay, I pick Garrett.
Garrett. Okay. So, Garrett, we have a kind of a hot mess here because we have this negative exponent and we have this negative exponent and we have this negative exponent out here on the outside. So when you're trying to figure out even what to do first, what is a good first step?
Get rid of the print.
Yes. So if we want to get rid of the parentheses, that means we are going to do this multiplication by -4 right away.
Yeah.
So if I rewrite that, this is 12, that's by itself, and then this is y to the -5th by itself, and we're going to like distribute those. So if I rewrote it separately, then I have 12 to the -4th, and then how about the y? What does the y become?
Y to the, well.
Do you remember what to do when you multiply exponents?
Yeah, so it would be y to the 20th.
The 20th, excellent, right. So what he did was a -5 times a -4 right there, and that equals a +20. All right, so that's the part that's on top. Now, let's look at our denominator because this -4 goes the whole way. It's not just the numerator, it's the whole thing. So that's going to be 15 to the -4th. And then what happens to the y here?
Y to the 12th.
Y to the 12th. Y'all see that? Because it was a -3 times a -4, creating a +12. Okay, that was a good first step. Now, what do you want to do?
So we're trying to simplify, trying to break down some of those numbers.
We're trying to simplify as best we can, right?
So would you try to simplify the 12 to the -4th and 15 to the -4th?
Yes. How do you want to simplify 12 to the -4th? There's a couple different ways you could go with this, so I'll let you decide.
Maybe 1 to the -4th on the top and bottom.
What do you mean 1 to the -4th?
Like, what is it where you, I can't remember what it's called. Like you divide by it or something?
Are you talking about factoring, maybe?
What?
Possibly?
Yeah, I think so.
Okay. So even though in problem 1, I said that we could leave this -5 where it was in terms of simplifying, in a case like this, it still is probably a good idea to try to get rid of these negative numbers. So just like you moved the x, so like for example, this was 12 to the -4th over 1. That is going to equal the same thing as 1 over 12 to the 4th. You can still make that.
Oh, okay. So you just have over 15 to the 4th, and then top 1 over 12 to the 4th.
All right. So if we do that, I'll put my arrow up here so you know where we moved. Then we can have 15 to the 4th y 20 over 12 to the 4th y 12. And now we've completely gotten rid of all of the negatives, which is helpful. Okay, now from there, let's do the factoring thing. So, because that's going to help us simplify without making huge numbers. Because we could do 15 times 15 times 15 times 15 and 12 times 12 times 12 times 12 and then figure it out from there. But if we don't have to have those huge numbers, let's not give ourselves the headache, especially in July. So, Garrett, what are the factors of 15 and the factors of 12?
Well, it could be, for 12, it could be 2 and 6. But that
Right,
would,
so that starts it. Then what are the factors of 6?
2 and 3.
2 and 3, right. Okay, and then what are the factors of 15?
3 and 5.
3 and 5. So, if we do that, I could rewrite the 15 as 3 times 5 to the 4th power, and that would be the same thing, right? It's just 15 and y 20. And then on the bottom, for the 12, I could put 2 times 2 times 3, because that's 12, to the 4th power, y 12. Now, I can do some canceling in our integers. What can I cancel out on the top and the bottom?
3.
Yeah, it's actually 3 to the 4th power right there. That's going to go away. That became like a 1. So we're getting a little bit simpler step by step. That's leaving us with 5 to the 4th power y 20 over 4. I'll go ahead and multiply those back again, to the 4th power y 12. So this part, we aren't going to be able to divide that evenly, so we're going to leave the integers alone. Let's take a look at what we can do with this placeholder here. What can we do to simplify that, the purple section?
Factor them.
I'm sorry, Garrett, say it a little bit louder.
Do like we did with the other numbers.
Well,
12 and 15.
let me give you a sample over here. If you have exponents in a numerator, like a 21, and you have exponents in a denominator, like a 3, that's the same thing as 21 minus 3. That would equal y to the 18th power. So this one and this one can actually get combined.
Okay, so it'd be y to the 32nd.
But you subtract. If one is in the numerator and one is in the denominator, you subtract the denominator from the numerator.
So y to the 8th.
Yes. Excellent. Okay, so now we have 5 to the 4th, y to the 8th in our numerator, and then our denominator has 4 to the 4th. Okay, now to make it the most simple, the last thing we need to do is we actually are going to have to do this part of the multiplication. So
16 and 20.
4th is that 5 times 5 times 5 times 5?
Wait, no, oops. That'd be 25, 125. $625.
All right, 625 y to the 8th power is our numerator. And then the denominator is that 4 times 4 times 4 times 4.
Can I use a calculator?
Oh, we're so close. 4 times 4 is 16. What's 16 times 4?
56. No, wait. Yeah.
4, 2, 200 and no.
Is it
that's
4,
not
not 56?
Yeah. We were so close. 16 times 4. I gotta do that one right. 4, 2, 64. There we go. So 64 times
Final
4.
answer 256.
Thank you. That is correct. 256. Sometimes we'll let you use calculators, but for things where we can figure it out, we gotta exercise our brain. So even though I went way too far down on the page, this is the simplified answer to number 2. 625 y to the 8th over 256. All right, that one had a lot of tricky steps in it. Let me go back.
I have a question.
Yes.
Can you go back on the page again?
Yep.
Yeah. Okay. Where the arrow is, what? Can you explain that part again? Because I'm kind of confused in that part.
Can you see my mouse?
Yes.
All right. Which arrow? I have an arrow here.
The one that's going up. The 15 and then 4. 15 to the power of 4.
Up
right
here?
there. Yeah.
Okay. Yes, I can. So we were just trying to simplify this part, 15 to the power of 4 over 12 to the power of 4. In fact, since this thing is so crowded, let me just create a blank page here. Make it bigger. So we had 15 to the power of 4 that was divided by 12, right? That's what it was. 12 to the power of 4, not 4 to the power of 4. And if we were to write that out in big terms, not using exponents, it would have been 15 times 15 times 15 times 15, which is really big numbers. I would let you use a calculator for that one, over 12 times 12 times 12 times 12, and that's also a really big number. Because I wanted to see if I could simplify it first, because I didn't want to multiply those really big numbers, I decided to change the 15 into its factors. So I didn't, Garrett did. The factors of 15 are 5 and 3. So instead of writing 15 to the 4th power, that's the same thing as 5 times 3 to the 4th power, because 5 times 3 is 15. Or I could write that 5 to the 4th power, 3 to the 4th power. All of those mean the same thing. It's just different ways to look at it. So far, does that make sense, Diamond?
Yeah.
Okay. Then doing the same thing with the 12, the factors of 12 were 4 and 3, so 2, 2, and 3. So 12 to the 4th power is the same thing as 2 times 2 times 3 to the 4th power. Or I could write that 2 to the 4th power times 2 to the 4th power times 3 to the 4th power, because that's how you distribute the exponents. So looking at it, 5 to the 4th power times 3 to the 4th power over 2 to the 4th power times 2 to the 4th power times 3 to the 4th power. I see these are the same. So I can divide these. So 3 to the 4th power divided by 3 to the 4th power just becomes 1. And then I'm left with this part here to work with, which is going to be a little bit easier to work with. Does that make sense? Did I answer your question?
Yes.
Okay, great. All right, anybody else? Okay, you ready to try a Quizlet live that is using negative exponents then, so that we can kind of refresh that before we move on to scientific notation? Couple things to remember, and then we will try this live, see how it works. Again, if you are the winner of the live, you'll get some extra credit, and you're going to need an internet capable device. I think you can do it on your computer or your phone or whatever. It'll be like Kahoot in that sense. If you have a
I do not have a
Yes?
computer, so should I like sit out? I mean,
I think you could do it on a computer. I'm pretty
I
sure
don't
you
have
can.
access to one
Or what are you on?
phone, but that's it.
Then you can do it on your phone too. If you have a negative exponent in the denominator, you can move it to the numerator and it becomes positive. If you have a negative exponent in the numerator, you can move it to the denominator, it becomes positive. If you are having an exponent with the same placeholder in the numerator and the denominator, you can subtract them and move them up. If you have an exponent and then you have a parentheses and you have another exponent, so a power of a power, you multiply them. All right, let's see how this works. This is our Quizlet experiment. So I'm back on a shared screen. I'm gonna go over here to Quizlet, and if you're on a smartphone, you scan it. Once you go to www.quizlet.live, Jack got in right away, and the code is 112231. And I'll turn the music back on. There. I don't hear anything there. Hold on a second. Oh, there it is. Amazon. Dylan, Glob, Diamond, you guys are doing great.
What's the code again?
112231.
Got it.
Garrett, you made it on. So we need Sophia, Brady.
I'm in.
Sophia. All right, is everybody in? Is there anybody not in that I'm supposed to be waiting for?
So are we like doing these right now, or is?
All right, I'm gonna go ahead and start. See how we go. Sophia, you're the panda. Blob, you're the unicorn. Emma,
that
you're
good
the
dolphin.
sea turtle.
boy.
Grady, you're the dolphin. Garrett, you're a puma. Dylan, you're a bear. Jack, you're a wolf. Diamond, you're a frog. I'm gonna start the game.
Wait, so what are we supposed to be doing?
Answer the questions. If you get a wrong answer, it makes you go back to the beginning.
There's no what question? There's no question. I don't get this. What are we doing?
Panda, you're in the lead. Everyone else got kicked back.
Yeah. I just got kicked out. Whoops.
Try to get back in. The game code is 112231.
I did. It says waiting for next rounds. Until then, just sit
okay.
tight. So whatever. Go up.
We might do this again with a student shared screen so that the recording can show what it looks like on the student side, because I can't see the student side. I only see the scoreboard. Panda's cruising with 7.
I got kicked from the game.
Oh no, Panda's back at 0. Now Bear's in the lead.
It let me rejoin the game.
Sea turtles coming up. All right, careful, Bear. That's about where Panda messed up. Now Bear has 10 out of 12. Bear has 11 out of 12. All right. Bear. Who was the bear?
Dylan.
Dylan. Good job, Dylan. I am marking down that you're getting extra credit. Now, this time, I don't want you guys to play like you're playing to play, but I want you to watch, especially those of you who haven't done a Quizlet before. Dylan, can you do a shared screen, please? So I'm going to click play again. You can play, of course, but what I mostly want you to do is see how it looks on the student side if you are not sure how to make the Quizlet thing work. Basically, what we're trying to do is learn how to use Quizlet Live. So Dylan, I need you to do a screen share.
Of what?
Of whatever you play Quizlet Live on. Or are you playing it on a phone? All right, excellent. So I am going to go back into Quizlet here and just click play again and start it. And it said Emma, Jack, Glob, Garrett, and Brady were all disconnected. If those students want to rejoin the game, ask them to refresh the page.
What's the new join code? Never mind.
So let me turn off the music for just a second so I can hear y'all. So try to rejoin if you got kicked out. I see 8 people. Diamond, Garrett, and Brady, try to get back in.
It says I'm in. It says I'm still waiting for the next round.
Okay, good. Maybe my
Wait, what's the pin?
It's the same pin.
It's this, yeah,
I
1 1
I don't see it.
1.
What? You don't see.
Wait, say it again. It's what?
It's the 1 1 2 2 3 1. There, I see Brady now. He came in. And this time we're watching, like you all can see Dylan's screen, right? You should be able to. I'm going to go ahead and start it. Start game anyway. And we're going to watch what it looks like on Dylan's side. So you have your answers. You click on it. And as you click on it, if you got it right, it advances you forward. If you get one wrong, it kicks you to the back. Dylan, get one wrong on purpose so we can see how it kicks backwards. No, you still got one right. Get one wrong on purpose. I know you don't want to, but do it. There we go. So when you get a wrong one,
Fine, I
it
did it.
shows you what the correct answer is, and then you get to start over. Now you can do them all right, because we're going to watch it go to the end, and then we'll count that good, and we'll move on to scientific notation. So click away. Oh, look, some other people are going up ahead. You can see. Nice. And then we'll see how the game ends on the student side, too. I've never seen the student side at the game end. So this is new for me. Okay, so
Third.
Hedgehog is number 1. Excellent. Okay. I'm going to go ahead and stop the screen share and take a look at y'all for just a minute. Okay. Does
So I would have
everybody
won if you didn't make me do one wrong.
how it works? Does it make sense, the process, if we want to use Quizlet Live in the future?
Sure.
Did anyone have any, like, I couldn't figure out how to play the game at all? Or do you all understand how it works now?
It seems like the questions, I didn't make sense of the format, because like it's asking they have the numbers up on the screen and it's asking to put into positive exponents, but it's not asking for you to put into positive exponents. It's asking for you to find the negative exponent equivalent of the number that you found, and that was really confusing.
Got it. But now that you've seen it twice, does it make a little more sense what they were asking for?
Yes.
Okay, good. And we can make some of our own Quizlet lives. I just borrowed that one so that we could practice it for today. Okay, y'all ready to move on to scientific notation then? Say, woo, science, scientific notation, yes. Go back up here. Now I made a hot mess in my paper here because we needed to use our white space. When I'm writing the answers to problem 3 and problem 4, I'm just going to write them in a different color. And Garrett, I think you get to pick who is going to go next.
I pick me.
You pick you?
Yeah.
Why not? All right, what color ink do you want me to use?
Notation.
We have orange, green, blue, or black that are suitable.
Black.
Black. Okay. So when we're doing scientific notation, which is what it asks us to do, scientific notation is when you convert really long numbers with lots of digits into something that is more reasonable to see, and it's all on base 10. So it's all on multiples of 10. The final answer of scientific notation is going to have the decimal point right in the after the first integer. So you're going to have a number right here, and then you're going to have a decimal point, and then you might have a number here. You might have
the answer
here.
Good.
But it's always going to be times 10 to some amount. So if you are moving your decimal point to the right, like here, to get it into the correct location, then that is moving a negative amount. If you are moving it like over here in problem 14 and you have to move your decimal point this way, then you are going to have a positive exponent. So right there, that's going to go negative, and right there, that's going to go positive. Okay, so Garrett, looking at problem 3, and actually I'm going to make this a little bit bigger even so that we can really see it. All right, here's my decimal point. Tell me which way to move it and how many numbers I should move it.
To the left 6.
To the what direction?
The right. To the right 6.
Yeah, the other left, right? All right, 1, 2, 3, 4, 5, 6. There it is. That's exactly where I want it to be because I have the integer, one integer on the left side of my decimal point. So my answer then is 7.17 times, what do I write?
Times 10 to 6.
10 to the negative 6. Because when I have to move this direction, my decimal point, it's negative. See right there? So this is the answer to problem 13. It's the exact same number. It's just written here in a different form. 7.17 times 10 to the negative 6th. Okay, Garrett, pick somebody else.
I'll pick me again.
Well, I didn't say you couldn't, so let's go over here and do problem 4. This time I moved to green, though.
The answer for the next one is 1.86 times 10 to the 7th.
1.86 times 10 to the 7th is correct. What Garrett did is he went 1, 2, 3, 4, 5, 6, 7. That's where we want our decimal point to be, so that the 1, you have one digit on the left of the decimal point, and then however many other numbers you have. And then because we went this way, it's a positive exponent versus this way where it's a negative. Excellent. Okay, Garrett, now you need to pick somebody else.
Dylan.
Dylan, you are going to be working on problem number 5 here, which is still using the scientific notation. We have 8.6, I'm going to go back to my red because now I have room back on my paper. 8.6 times 10 to the negative 8th times 7.3 times 10 to the negative 6th. What in the world do we do to solve a problem like this one?
Ask for help.
Ask for help. All right, here is your phone a friend. We're going to deal with our numbers first, and then after we deal with our numbers, we're going to think about the base 10 part of this expression. So 8.6 times 7.3, that we can figure out. What's 3 times 6?
18.
All right, so I put the 8 down there, carry the 1. What's 8 times 3?
24.
Plus 1?
25.
All right, so I multiplied my 3, which was my single units. Now to multiply my tens, I'm going to have to put the 0 down there. What's 7 times 6?
42.
All right, my 2 goes down there. My 4 goes up there. What is 7 times 8?
56.
Okay, plus 4?
60.
All right, now I add. So I have an 8, I have a 7, I have a 2, I have a 6. Dylan, what do I have to do to put my decimal back in? Where does it go?
2 spaces to the left.
Yeah, so you always count how many numerals are behind the decimal point, and then starting here, you go that way, that number. So there's a 6 and a 3, which is 2 numbers. So starting here, I go back 2. So now I have 62.78 times 10 to the negative 8th times 10 to the negative 6th. So what do we do now? Let's take a look at our other side for just a second. Let's look over here. How can we combine these, Dylan? I'll give you a hint. When we multiply exponents,
So you add the powers.
we add the powers. So it's going to be 62.78 times what?
10 to the power of negative.
Sorry, 10. My phone rang. 10 to the power of what?
Negative 14.
Yes. All right, so now we're looking really good, except we have to go back to our numbers over here. This is not in scientific notation form anymore, is it? We're going to have to move that decimal point. So think of how Garrett moved it before. It has to go right there, which means
But
it
14
went
times.
to the left, right?
Yeah.
So it's going to be 6.278. When we pull that out, you know what happens here? Times 10 to the...
Yeah. To the power of negative 13.
Yes! Excellent, Dylan! Woohoo! You got it! Does everybody understand how he got 10 to the negative 13 instead of 10 to the negative 14? Because right here, when he moved his decimal place over, That was a multiplying it times 10. Okay, excellent. Dylan, pick somebody to do problem number 6 then.
Who hasn't gone?
I don't know. I know Garrett's gone. Garrett's gone a lot. I don't know if Emma has gone recently anyways. I don't think Sophia's gone.
Okay, then Emma, I guess.
Emma, okay. So you have a similar situation in that you're going to deal with your numbers, and then after you deal with your numbers, you're going to deal with your base 10 over here. So what is 3.2 divided by 2.5? Or if you can't tell me, what strategy should I be writing down here to find out the answer?
Don't you write down a long division line thingy, and then it's the 3.2 dividing 2, or that one.
All right, now I can't divide by a decimal, so before I start figuring this out, what am I going to have to do?
You're going to move the decimal point over on both numbers to the right.
All right, when I move it over, I'm just going to go ahead and write it on top, because then I don't have to think about it anymore, and I can use any number of zeros I need to get my answer. All right, how many times does 25 go into 32 without going over?
Once.
So there's our 25, and when we subtract, what do we have?
7.
And then we're going to pull down a 0. How many times does 25 go into 70 without going over?
Twice.
Twice, and that's 50. And when we subtract, sorry, it's over there, 20. And then I'll pull down a 0. I know that's not good form, but there we go. How many times does 25 go into 200 without going over?
8.
8. All right, and then that was actually 200, so that's it. So we have 1.28.
Wouldn't behind the 2 there be a 0 and then the 8?
No, because we had 20 down here. I'll write it and I'll erase it. And then you just pull down a 0.
Oh, okay.
Okay. So 1.28 times 10 to the 9th divided by 10 to the 6th. Now it's time to work on this part over here. How do we simplify that?
Do you subtract them?
Yes, yes. So the relationship between these two, you subtract.
So it would be times 10 to the negative 3rd.
It's 9 minus 6.
Okay, so then to the 3rd.
10 to the 3. 1.28 times 10 to the 3rd power is the correct answer to number 6. Okay, that is the end of our practice with scientific notation. Does anybody have any questions about scientific notation before we move on? Going once. Going twice. Okay, moving on. Emma, pick somebody else to simplify down here.
Glory.
Glory. All right, you're doing problem 7. And when we have a single variable, like we do right here, we are wanting to see what we can do, but we don't have any sort of an equality sign. There's no equal sign or greater than. So we're not going to be able to get an answer. We're only going to be able to make the form look simpler. When you're trying to do that, you are following the dance like people and zombies are outside as much as possible. So what is the first step you're going to want to work on, Glory?
Distribute.
Yes, right here, we're going to want to distribute, which means you're going to multiply that way and you're going to multiply that way. So we have 6, and then what do I write?
Does the negative number get included in that too? Or is that if
that's
just it's
the
on the other
easiest
side?
way to think of it. Negative 2 times 3x.
Minus 6x
Minus
plus
6x
30.
Plus negative 2 times 10. I don't know.
Times 5?
I'm sorry. Yeah. -2 times -5.
Yeah. 10 plus 10.
10. There we go. All right. Now this is what we have. 6 minus 6x plus 10. Are there like terms that you can gather?
Yes.
What are they?
The 6 and the 10.
All right. So one step simpler. This problem looks like what?
16 minus 6x?
Yep. Now, can we combine those in any way?
Nope.
Are we done?
Yep.
Yes. Excellent. That feels refreshingly easy compared to some of the other stuff we just did. All right, Glory, pick somebody for problem 8.
I choose Brady.
Brady. Okay, so we're doing order of operations here, which is, please excuse my dear Aunt Sauerkraut. What is the P? What does it stand for?
Parentheses.
Parentheses. Do we have something in parentheses? Brady, do we have something in parentheses?
Yes. Would it be -5 or
So what is 3 minus 8?
-5?
-5. You sound like you're in a tunnel. Okay, 25 minus 5 squared plus 20 divided by 2, and then you said that was a -5. All right, we did placeholders. What does the E stand for?
Exponents?
Do we have exponents?
Yes.
What is it?
25.
Well, just tell me which one is the exponent we're going to deal with.
The 5 squared.
Excellent. All right. So 25 minus, all right, what's 5 squared?
25.
Okay, and then I'm just going to write it all out. The secret to these problems is being very meticulous and doing just a single step at a time. All right, we got rid of all of our exponents. Now, multiplication and division, they have the same value. You don't do multiplication before division. They are the same step. So if you have both, you always go from left to right. So what is the first multiplication or division that we have?
The division part?
This one right here?
Yes.
All right. What is 20 divided by 2?
10.
10. All right. So we have 25 minus 25 plus 10 times -5. All right. Now, Brady, what's our next step?
To multiply.
And here's our multiplication right here.
So that would be -50.
We have 25 minus 25 minus 50. All right, multiplication and division are done. Now we're left with addition and subtraction. And again, you just go left to right. So what's 25 minus 25?
0.
What's 0 minus 50?
50.
What kind of 50?
-50.
Yeah, 0 minus 50. We are left with -50 as our answer. Excellent. Sometimes these order of operations problems can get really, really, really complex. My girls know I started working as an online tutor and with a national company that does tutoring. And this week I was working with a middle school student on order of operations, and I had an exam that was created by this national company, and it was an order of operations problem like this one. They got the wrong answer. They made a mistake in the steps along the way and didn't do division before multiplication in the same line in left to right. And I had to contact the company and tell them that their test was wrong. So if a national tutoring company can make a mistake, a student can make a mistake. As long as you are slow and meticulous and careful, you should be fine. Any questions on anything on page 101? Because if not, we are flipping over to page 102. Everybody good? Everybody still alive? All right. Brady, you need to pick somebody to work on problem 9 here.
I picked Jack.
Jack, Brady loves you so much.
Oh, that's gay.
Isn't that sweet of him to pick you to do this problem? Okay, Jack, before you have to think about this, because again, we are getting higher up. If you wanted to look where this was from, this is from Unit 6, Part A, Lesson 5. So we are, going way farther up here. The first thing that you are going to need to do before you can do this big part, because you have these expressions in a numerator and expressions in the denominator, you aren't going to be able to do the big part until you deal with just the numerator and make it a single term. How many terms are there right now? This is your clue.
2.
2. Yeah, this is a term and this is a term, and this minus sign is connecting them. That's not going to work for us. So let's work on this numerator first. 1 over x minus 1 over y. Can I just subtract these as they are right now?
Repeat that, sorry.
Here, let me show you like if it was a different fraction. If it was 1 over 3 minus 1 over 2. So I substituted like that was the x and that was the y. Can I subtract those fractions like that?
Yes.
No. If you want to add or subtract fractions, they must have a common denominator first. So we are not going to be able to do anything with this x and y until we get a common denominator. So thinking about that, what can the common denominator be with x and y? We're going to have to multiply 1 over x by something, and then we're going to have to multiply 1 over y by something. What is going to be the common, the least, like think of the least common multiple that they both would be able to have. And again, let me give you the example over here. If it was 3 and 2, what is the least common multiple of 3 and 2?
6.
6. And you knew that because it was 3 times 2, right? So if you think of that as like the x and that like the y, that should give you a strategy. What are you going to want to multiply 1 over x by? Because what is the common denominator that you're looking for?
Multiply it by x over 1.
Well, if you did x over 1, then that's not, this number right here doesn't have a value of 1. And whatever we multiply here has to be the same in the numerator and the denominator. Otherwise, we're going to change the value of our term. Let me give you a hint. You want the common denominator to be xy. Like here, this was 3 times 2. You want it to be x times y. So if I have 1 over x, and I need it to be something over xy, what is a fraction I can put right here that has a value of 1? So it's the same thing in the numerator and the denominator.
1y.
Y over y, right? Y divided by y, that equals 1, because anything divided by itself equals 1. Now, 1 times y is y, and x times y is xy. You see that?
Yes.
All right, so this fraction right here is now y over xy. Then we need to do a similar operation with this 1 over y. So what are we going to multiply 1 over y by, to have something that has xy in the denominator?
X over X.
X over X. Excellent. So 1 times X is X, and then Y times X is XY. YX, XY, it makes no difference. Goodness. Okay. So now we have this thing, and we have this common denominator. So now we can subtract. What is going to be our new term here for the numerator? This is still you, Jack, and then we'll pass the denominator to somebody else.
X, Y.
So y minus x, you just go ahead and put that right up there, over, and then what do I put in the denominator? Here's an example. Like if I have 1/3 plus 2/3, what is that going to equal?
XY. Or, well, it's going to equal.
Yes, right. Exactly. Because that would equal 3/3. So the denominator just carries right on through. You don't add it or anything. You just keep it there. All right. So that means this part, I'm going to put a square, not a circle, because it's not the end. This is now what we are going to use for our numerator. And we can, it's the same value. And the reason why we want it this way is because this is a single term. And we needed it to be a single term versus over here it was 2 terms. I know this is a lot trickier than the other things, but you guys are doing good. Okay, Jack, pick somebody to work on the denominator for us.
Dylan.
All right, so Dylan, 1 divided by xy is our denominator. How many terms is that?
Uno.
What's that? Uno.
Uno.
Yes, I heard your Spanish. So that means this one doesn't need simplifying. Jack was nice and he gave you a nice easy one. So we have y minus x over xy divided by 1 over xy. That just looks terrible. So when you have fractions divided by fractions, you always want to write it in the horizontal mode instead of the vertical mode, because it will just look a lot easier. So if I take the same thing and I put y minus x over xy divided by 1 over xy. Dylan, I'm trying to divide 2 fractions. What rule do I need to follow?
The rule of getting a calculator.
No, we can't. This is what we change. Here, I'll show you an example. If I had 3/2 divided by 1/8, that's the same thing as 3/2 times 8 over 1.
Okay.
You remember that? The
Yes.
division turns into multiplication, and you just flip the numerator and denominator of the second fraction. So you multiply by the reciprocal, and that's the same thing as dividing.
Okay.
So if we do that, then I have y minus x over xy
times xy over 1.
xy over 1. Okay, can we simplify?
Yes.
Yes. What can we cancel out?
xy and xy.
All right.
They
So when
both
we do
become
that,
1.
what are we left with? You still multiply the
Oh,
numerator.
y minus x over 1.
Y minus x over 1. And can we simplify that?
No.
Just write it this way, y minus x, because anything divided by 1 is just itself. So this is the exact same value as how we started in problem 9. It's just much, much, much simpler looking. Okay, that was a tricky one. I'm going to actually write problem 10 on a different page because I used up all my space here on problem 9. I went overboard. So Dylan, pick somebody who's going to work on problem 10 for us, please. You need to say their name out loud because I didn't hear you.
Garrett, I guess.
Who is it?
Garrett.
Garrett. All right, Garrett. I'm writing it over here. Let's see. We have 2 divided by x plus y divided by 4 divided by x plus y. Okay, Garrett, how many terms is this?
2.
It's actually just 1 because it's 2 divided by x plus y. So division and multiplication don't separate terms, only addition and subtraction. So that's good news. It means you don't have to simplify first. How many terms is 4 divided by x plus y?
1.
1. All right. What did I say was the first step that you want to do so that it doesn't look so confusing when you're dividing fractions by other fractions? Let's write it horizontally instead of vertically. So it's the exact same thing. 2 divided by x plus y divided by 4 divided by x plus y. Okay, so Garrett, we're trying to divide 2 fractions. What do we do?
Try to simplify it.
Well, first we're going to change that and we're going to change that. So instead of division,
Well, it ends up being 2 over x, y, f times
right?
x plus y over 4, which
Yes.
would that was the other x plus y, and you'd be ending up with 2 times 4.
2 divided by 4.
Oh.
Right?
Yeah.
Because you're multiplying the numerator, so that's 2, and you're multiplying the denominator, and that's 4. And then can you simplify 2 over 4?
Yeah, it ends up being 1/2. 1/2.
1/2, exactly. There, nice and simple. So 1/2 is the exact same value. We didn't change the value at all as what we started with over here. It's just in a much simpler form. All right, very good. Let me go back up here. And problem 11, I'll probably write on the next one too, because it looks like I kind of took space out of 11. So Garrett, pick somebody to work on problem 11, please.
Diamond.
Diamond. Oh, wow, girl. Okay, here we go. I know it looks terrible. It's not going to be that bad. Over k plus 2. Okay, so diamond, how many terms is this numerator?
1.
1. How many terms is this numerator?
1.
1. Is this one 1?
No.
No. So what we're going to do for this problem is we are going to factor this thing right here. So if I have k over 4 in my numerator, and I'm trying to figure out what are the factors, what goes in this location of my parentheses?
1.
Well, we're trying to get this something times something equals k squared.
Chair.
It's going to be K
Okay.
times K. Remember? I know it's been a while. K times K is K squared. And then if we work on this part, the 2, what are the only two numbers that we can multiply to get 2?
1
1 and 2,
and 1.
right?
2.
So let's check to make sure that we have this right. K times K is K squared. K times 2 is plus 2K. 1 times K is plus 1K. And 1 times 2 is plus 2. So K squared plus 3K plus 2. That's what we started with. So we factored it correctly, which means now we could write K to the 4th power over K plus 1 times K plus 2 divided by 16K to the 3rd power over K plus 2. All right, now we have all factors. We don't have any plus signs or minus signs that are messing things up for us. So, Diamond, what are we going to do about this dividing by a fraction? How are we going to change that format so that we know how to do it? What is the divide here going to become? I have an example on the other page, I think. Oh, I erased the example. So I'll write a new example because this is, it's been a while since we've worked with fractions, but like 1/3 divided by 2/5 is the same thing as 1/3 times 5/2. So your divided sign becomes a multiply sign, and then your second fraction you invert. So the 5 goes on top and the 2 goes on bottom. So can you use that same strategy with what we have? Oh, I think I move up. There we go, up here. So instead of the divided by, what's it going to become?
So 16K to the power 3. Wait, do we flip them?
Yep, you got to flip them. So it's going to be times
K plus 2
over 16K to the power 3. Okay, before we multiply, can you simplify then? Do you see any common terms we could knock out in numerators and denominators? What can we knock out?
K plus 2.
Yeah, that becomes a 1 right there. Good. So that means I'm going to go ahead and make this like one big long fraction sign. I'm left with K to the 4th on top over K plus 1 times 16K to the 3rd power. Now what do we do? This one and this one we can simplify. So when you have exponents in numerator and in denominator, you subtract.
So
draw my arrow this way. What's now in my numerator?
K to the 1st?
Yes. And K to the 1st power is just K, so I'm going to leave it up there. And now, what's in my denominator?
K plus 1
times
16.
16. There it is. Yep. You made it, Diamond. This is the final answer. Now, if somebody wrote k over 16k plus 16, if they went ahead and redistributed, that would not be wrong, but this is the answer that was in the answer key. So that one was a tough one too. We're just in harder territory right here. Does anybody have any questions about problem 11 before we move on to problem 12? Okay, Diamond, pick somebody to do problem 12.
Sophia.
Sophia! You were being so quiet, hoping that people were not going to notice you, right? But here you are. All right, this time we are not dividing fractions, thank the Lord, but we are adding fractions. So what is the basic rule about what needs to be true before we are able to add two different fractions?
The denominators have to be the same.
Yes, we need to have a common denominator. So, looking at what we currently have, we have an x minus 4, and then we have an x squared minus 16. Because this is a problem from a math book, I'm fairly confident that if we factor this x squared minus 16, that's going to give us a good clue into what our common denominator needs to be. So if you are trying to find the factors of x squared minus 16, what goes in this location of your parentheses?
X.
Yeah, x times x makes the x squared. And then this particular case is we call one of the special cases. It's that difference of two squares, because x squared is a square root, like, the square root of x squared is x, and the square root of 16 is 4. So we already know what needs to be in the rest of these parentheses if we follow the formula, or we can figure it out. Do you know what to write for the rest of them?
I think it's a +4 and a -4.
Yes, exactly. So when you have the difference of two squares, it's the square root of both of them, and then one of them is positive and one of them is negative. Now, having seen that, we can see, I see this is a common factor in both of them, this x minus 4. So it's not going to be too hard to convert this first fraction into having the same denominator as the second fraction. What are we going to have to multiply this first fraction by? It already has the x minus 4. What's it missing?
The x + 4.
Yeah, so we're going to multiply it by x plus 4 divided by x plus 4, because anything divided by itself is 1. So let me write it over here where we have a little room to see. X minus 4 times x plus 4 divided by x plus 4. Okay, what is that going to equal in our numerator?
2 times x + 4.
Over, and now we have this common denominator, x minus 4, x plus 4. So if I'm just going to erase this part right here, because I need more room to write. There we go. If I write it this way, 2 times x plus 4 plus 3x over x minus 4 times x plus 4. All right, Sophia, what is the next step we need to do to simplify this?
Is it distribute?
Yeah, we're going to have to distribute right there. So tell me what to write and I will write it.
2x + 8.
Then we have our plus 3x over x minus 4 times x plus 4. Okay, are there any like terms that we can combine?
Yes. On the top, there's the 2x and the 3x.
2x and the 3x. All right, when we combine those, what do I write?
5x plus 8.
And then we have the x minus 4 and the x plus 4. Okay, is there any other way we can simplify this?
If you like multiply the bottom two.
Well, we could, but that's not going to really help us later on because whatever we have to do with this is probably going to be easier in the factored form. We cannot combine the 5x and the 8. They're not like terms. So this is good enough as your simplified answer. If you had done what Sophia said and you had 5x plus 8 and then on the bottom you put it back as x squared minus 16, that also is okay, but you don't have to. This one right here is the way that the book has it as the correct answer. And this is the one that will be most helpful to you later on when you're trying to figure out how to solve for x or something like that. Excellent. Okay, 4 problems left. We're gonna make it. Sophia, pick somebody to work on 13, please.
Emma.
Emma. All right, 5x minus 2 squared is the same thing as 5x minus 2 times 5x minus 2. Be very careful. A lot of people will commonly make the mistake and think that it is 25x squared minus 4, and they will skip the middle part of the distribution. So do it piece by piece. You're going to multiply that, you're going to multiply that, you're going to multiply that, and then you're going to multiply that. So 4 times. Tell me what to write, Emma.
Okay, 25x to the second, and then negative 10x, and then another negative 10x, and then negative 4, or positive 4.
Positive 4. Okay, are there any like terms you can combine?
Yeah, the 10x's.
Minus 10x and minus 10x becomes what?
Negative 20x.
Okay, negative or 25x squared minus 20x plus 4. Is there anything that you can combine now?
No.
Then this is your answer. You got away easy. So notice this is not asking us to simplify, it's asking us to multiply. So this is kind of like the opposite procedure of what Sophia was doing higher up, where she was simplifying it from a multiplied state. This is multiplying it from a simplified state. All right, Emma, pick somebody for 14.
Jack.
All right, so Jack, it's the same thing. You're going to distribute here, and then 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 you are going to distribute here. So 6 times in total. And if you're afraid that you're going to forget one, you can always check. There's 2 terms here, and there's 3 terms here. That means when you write out initially, you're going to have 2 terms times 3 terms. You're going to have 6 terms, and you can make sure you have 6. So tell me what to write. Start with the 4a times the 3a squared.
Okay, so 4a times 3a squared is 12a cubed.
Yeah.
4a times negative 2a is negative 8a squared.
Nice.
Then 4a times negative 1 is negative 4a.
Mm-hmm.
Then 1 times, or 1 is 3a squared. Then 1 is negative 2a. Then 1 is negative 1.
All right, and so let me just count to make sure that we have our 6 terms. 1, 2, 3, 4, 5, 6. They're all there. Now you just need to combine like terms. What like terms are you going to be able to combine here?
The 8a squared and 3a squared, which would be negative 5a squared.
So we have 12a cubed minus 5a squared. And then what else can we combine?
4a and 2a, which would be negative 6a.
minus 6a, and then we're left with a minus 1, right?
Yep.
All right, that's it. He's all done. When you write the answer, make sure you always go in descending order of the variable. So there's a to the third, there's a to the second, there's a to the first, even though we don't write the 1 there, and there's a to the 0, because a to the 0 is 1. So 3, 2, 1, 0, they're all there. They're all accounted for. Great. Okay, 2 problems. We are not going to make it in 2 hours. We're going to be done early. You guys are doing fabulous. Jack, pick somebody for 15.
I choose Bradley.
Bradley, did you say?
Yeah, he chooses me.
Is that you? All right. So when you think of the special cases we learned with our polynomials, we had the difference of 2 squares. And then we had the difference of 2 cubes. And then we had the sum of 2 cubes. And then we had the perfect square trinomial. This is one of those special cases. Which special case is it?
Difference of 2 cubes.
Difference of 2 cubes. Excellent. Which means we don't really have to factor it if we remember the formula of how you do a difference of 2 cubes. Do you remember how to do that?
I do not.
All right. I will tell you. Starting with over here. You take this factor,
M.
and that's going to be m. And then over in the other parentheses right here, m times what is going to be that m cubed?
Cubed.
I think this is m to the 1.
Oh, and the other one's m to the 3. M cubed.
It's going to be 2 because it's 1 plus 2.
Oh, right.
So that one's going to be m squared. And then what you do for the rest of this first shorter one is you keep the same sign, so it becomes a minus. And then you do the cube root of 8n cubed. So what's the cube root of 8? What times what equals 8?
2.
2. And what's the cube root of n cubed?
N.
Yep. All right, so that part is all good. M minus 2n. What you do for this other part, because this one is a trinomial, is think of here, 2n times what is going to be that 8n cubed?
Repeat that again, you cut out.
So you're trying to think of 2n
Right.
times what
4n.
is going to equal this 8n cubed. So what?
4n squared.
There we go. 4n squared. So now all we are left with is what belongs in the middle, right? This is the only
Right.
part that we're missing.
Right.
What you do is you take this and this and this, and that's what goes in the middle. 2mn. That's how you do the difference of 2 cubes. If you don't remember that, and you definitely want to check to make sure you did it right, then we're just going to multiply out as our check. So m times m squared is m cubed. M times 2mn is plus 2m squared n. M times 4n squared is plus 4mn squared. And then minus 2n times minus 2n times m squared is minus 2m squared n. And minus 2n times positive 2mn is minus 4mn squared, and then minus 2n times 4n squared is minus 8n cubed. Those cancel, and those cancel.
So your final answer is m cubed minus 8n cubed?
Well, that's not my final answer. That's my check to make sure that we factored it correctly. Your answer, because it asked you to factor it, is this part right here.
Okay. Nice.
That's it. Those are the two factors that create this binomial, which it happens to be a difference of 2 cubes. Okay, we have one problem left. Brady, who do you pick?
I choose you.
You choose me?
Yes.
Okay, fair enough. It is late. This one is not a perfect square trinomial. It is not a difference of 2 cubes. It is not a difference of 2 squares. It is not a sum of 2 squares. So this is that general trinomial, which we do by trial and error. So when I think of this 6x squared, there's a couple different ways you can get a 6. It could be 6 times 1, or it could be 2 times 3. I don't know yet which it's going to be, but those are my two possibilities. When I think of the different ways I could multiply two numbers and get 15, it could be 15 and 1, or it could be 3 and 5. I don't know yet which it's going to be, but it has to be one of those combinations. I see this right here being a negative. The only way that can be a negative is if one of my factors is positive and one of my factors is negative. So I'm going to go ahead and do that. And the fact that this right here is only a 1 kind of makes me think that I want to use these numbers rather than these numbers, just because they look like it will be easier to make something that would have a value of 1. So I am guessing there, you just have to kind of figure out general ones. It's trial and error to see how it goes. Let me go ahead and put 3x and 2x. So I'm trying that combination. And then 3 and 5, and I'm trying that combination. So I have to see how this goes. Let me go ahead and change colors here. 3x times 2x is 6x squared. 3x times negative 5 is minus 15x. And then 3 times 2x is plus 6x. So I look right here. I'm like, oh, shoot, that's not going to create 1. That's going to be negative. So that's no good. That means my first try was a bad try. Let me flip these ones around and see how it goes this way. What if I have a 2x here and then a 3x? If I do that, I still have my 6x squared, and it's minus 10x plus 9x, and it's like, oh, well, this is close, because this would be that negative 1, and it's a 1, but I need it to be a positive 1. Whenever you're really close and it's just a negative instead of a positive, try to flip again. So instead of the 3 and the 5, I'm going to flip, I'm going to try to flip those around, and I should be there. You sometimes can get these first guess. Sometimes you could work on it for 20 minutes before you get it. There's not really a great trick with general trinomials, except the more you do them, you'll start to get a sense, kind of what works. So let me try this. The 3x times the 2x, that's my 6x squared. 3x times 3 minus 9x. Then 5 times 2x is plus 10x. And then 5 times 3 is minus 15. So this is the part that I really care about. Minus 9 plus 10 is going to give me that 1. 6x squared plus x minus 15. This is my check up here. That's exactly how I started, which means I found the right answer. And it is, these are the two factors, 3x plus 5 and 2x minus 3. Okay, that's it for today. If you're like, oh gosh, factoring polynomials, I remember why I needed summer vacation. Go back and check in Unit 6, Part A. Unit 6, Part A has the videos that talk about factoring polynomials. These 2 pages, 101 and 102, are your homework for this week. We will meet next week for the final time for the summer. Same time, same channel. Does anybody have any questions before I say goodbye? All right, good job, everybody. Well done, and I will see you next week.
Bye. Thank you.
Bye.